Okay, so we are live now, and yeah, so I'm back. I was off for a couple of days. I think for like 3 days now. I think I was under the weather, but yeah, good to be back. We were we were doing this section of the Ross language reference, which is iterating over results. We had like, I mean, we need this for the Rust book, right? So we want to rustling, sorry, we want to solve rustlings, and this is one of the things that was required, right? One of the sections that's required there. So yeah, what I mean is this. So when you in rustlings and for error handling, one of them is this section boxing errors, which actually is this, right, under error handling. So we just decided to solve everything. So let's continue from where we left off, which is iterating over results. And yeah, so this is I had like a program that I had written that we were doing, we were working with, right? So this is the code we had. I think we were working with this one earlier. So we've seen a map and map error, right? On the results, we've seen map and map error. We've also seen filter. We've seen filter map. Yeah, that's what we have here. We've seen filter map, how to use it and how to collect into a result. We saw that previously. So yeah, let's now look at just a second. Let me make sure that, yep. So yeah, let's see. So let's see where we, yeah, this is, I think I'm trying to recall where we left off. So yeah, there's filter map, yeah, and then map error. Yeah, we saw this part. Okay, I remember this is where we left off. So I think we were going to continue with this, filling the entire operation with collect. So how does this one work? So it says that result implements from iterator, so that a vector of results, as a vector that has results, can be turned into a vector. Okay, so basically, so result implements from iterator. I guess this is a trait, yes. So that's a vector of results. So you have a vector that contains results, that contains the results items, yeah, can be turned into a result with a vector. So you have one result, and then you have a vector in it, right? As the a vector in it as the OK, yeah, in the error. I think this is similar to what you do with when you say dot OK on an option, right? So sorry, on a result. So you can also turn a result. I think, wait, hold on. Let me confirm that part. So Rust standard reference. Let's see. Um, why is that taking some time to load? Do I have problems with my internet? Anyway, that would open up. Um, while that's doing that, uh, so I think what I wanted to check again is, I think I also have it somewhere here, right? Um, is it not here? No. Where you can basically, so you can have a result, and if you want to turn a result into an option, you can, and you can turn both of them, right? So it does take some time to load. I'm not sure what the issue is, but yeah. Anyway, let's continue. But we see that there's, okay. I think this is finally here. So there's like, I think it's on result, and yeah, and I think you can do uh dot okay. Yes, exactly. So you can do okay, which will convert the result to an option. Yeah, that's what I was referring to. And when you also have an option, you can go to a result. I think I'm trying to remember what. I think it's okay or yes, exactly. So it's okay or that gives you a result from an option. Okay, yeah. So we have these, and there's also transpose. Yeah, so transpose, it transposes an option or a result to a result of an option. Okay, this, yeah, okay. I was just trying to recall this, these operators you have on these things. So you basically have transpose um for option, and I think you also have it for results. Yes, yeah, exactly. So you also have transpose on results. So it transposes a result of an option to an option of a result. Yes, okay. So this reminded me of it anyway. But so anyway, what we have is a vector of result that can be turned into a result of a vector. And then it says once the result error is found, the iteration will terminate. So wait, how does from iterator work? Let's see. So you have this trait from iterator. So it's a conversion from an iterator by implementing, which for a type. Um, you'll be able to create a. Okay, so by implementing from iterator for a type, you can define how it will be created from an iterator. Okay. If you implement this, you can say how to create that. This is common for types which describe a collection of some kind. Okay. If you want to create a collection from the contents of an iterator, the iterator collect method is preferred. However, when you need to specify the container type from iter can be more readable than using the turbofish. That's like so, right? Okay. So you can look at the this for examples of that. So here we have examples. We say, so I mean how the from iterator implementation works. I think this is what, so let's see. So you have five fives and then you have what you have iter repeat five, take five. Uh okay. And then and this is actually a very cool one. I have not seen this on here. How does this work? I'm just curious. Wait, hold on. I want to see what we get, what this is doing. So let's write this code. I want to look at that. So what you have five fives, we have what uh we have ether, yeah. Um what is that? Yeah, repeat, okay. So you have repeat on it. It creates a new iterator and endlessly repeats a single element repetitive. Okay, it takes okay, does repeat. So infinite iterators like repeat are often used with adapters like take, to make them finite. So yeah, what does take do? Take. So it creates an iterator that yields the first n elements. Yep. Okay. Or fewer if the underlying iterator ends sooner. So take n will yield elements until n elements are yielded. Okay. That's so it's going to repeat five. Um take n, take five. Okay, that's what the five files is. But what is repeat actually a function? What is repeat? Hold on. Okay, we're already here actually. I think we can say, yeah, let's repeat here. By the way, repeat is a struct. So it's created by the repeat function. Okay. And if we say, yeah, so what is this? This documentation. So this is the repeat function exactly. Okay, so it's a function. Uh, okay, yeah. All right, that's fine. I think I saw what I wanted to see there. Let's continue now. I think we were looking at, so this is from Iterator. Um, I think I wanted to also see something. We wanted to look at something else from Iterator. Yeah, so we can do this take. We have this value, and then we can do um we can convert this now to the type that we want, right? So you can basically do from iter. So you can do vector from iter. And I mean this is because vector implements the from iterator. So let's see. I think if we go back to the from iterator, still be able to see the is it I think it's called. Can we see those are implemented? No, we can't. Okay, so but if I see vec, do we see are we able to um if I see vec, I think I want to check if we see the methods. Yeah, trait implementations. So does it implement from iterator? How does that work? Yes, it does. Okay, so that's how it works. Okay. So it implements from iterator, and that's why we can do that here. Okay, so collect an iterator into a vector. Come on, I didn't click on that. What are you doing? Yep. Okay. No, it's supposed to be. Yeah, it's all to see from iterator. Yeah. Okay. I mean, that's fine. I just wanted to see that. We've seen it. So you can actually call. You can say that the type and then from iter to convert um to convert to convert the iterator into the type that you want, in this case into vector. But you can also do this the other way. I mean, yeah, exactly. So you can do so by implementing from iterator for a type. So in this case, vec from iter, yes, which would then call this from iterator traits function. Yeah. So it specifies. So when you implement this for a type, you define how it will be created from an iterator. So how the type will be created from an iterator. Common for types to describe which describe a collection of some kind. So if you want to create a collection from the contents of an iterator, the iterator collect method is preferred. Yeah, I'm also wondering why we need this, or what the difference would be. If you want to create a collection from the contents of an iterator. Okay. Mm, okay, so this is when we want to create a collection from the content of an iterator. You collect. However, when you need to specify the container type, aha, okay, that's the difference here. When you need to specify the container type, this is just going to give you a collection, right? from the content of the iterator. But when you want to specify the container type, you can do the from iter. That says it can also be more readable than doing that. So I think what that means is this, that we can do a, so let's say we have a vector v. Yeah. So let's just say we have v. I don't know, 1, 2, 3, 5, or whatever. No, let's say 2, 3, right? For example, and then um we can do vec. Wait, vec, and then we can do from iter, and we give it the we can give it this, right? Because what from iter would take, hold on, from iter creates a value from an iterator. If I give it v, how would this work? Yeah, it would work. Okay. Mm, and then what if I did this? Okay. So we're here specifying the type. But if I then did it like so, if I did v dot iter, right? So where I get an iterator dot collect. So it's just going to be an iterator, right? To give me collector, yeah, exactly. To give me and take anything iterable, transforms an iterator to a collection. So okay, okay, okay. But then if we wanted to collect this to the vector, we would then have to do um, vector. We'll have to do this. I think it's not even complete because we have to do this and also like this for this to be complete, right? Mm. Okay, it says that vec either is gonna be built from an iterator over. By the way, I think I installed. Wait, what is that? I think I have. Correct. No. Anyway, okay. Anyway, I think we get the gist about this, about the from iter and that, right? So let's now see. So anyway, we so it's on this part. So now, so result implements from iterator, okay? So which means we can also do from iter on result, right? So that's what it means. So if I go to the result type, result in this enum here, we should see a from iterator. I guess this is it, yes. Okay. This is a from iterator. Um, implementation. So the trait is implemented here. The from iterator is implemented here, and this is the function, right? This is the from iter function, and this is so it takes each element in the iterator. So it takes each element in the iterator. If it's an error, no further elements are taken, and the error is returned. Should no error occur, a container with the values of each result is returned. Okay. So it will fail on so it will fail on the first error. So it's gonna fail on the first error, right? And return that error. But otherwise um it's going to return a container with the values of each result, the values of container values of each result. Okay. So here's an example which increments every integer in a row, checking overflow. So you have a vector with 1 and 2, and then you have result, you have rest that is a result that's defined to be a result, where the OK value here is the OK type is a vector of type U32, and then the error is not yeah the error type here can be a reference to a string slice that has a static lifetime, and this is um yeah, and this becomes what you take the vector and then you get an iterator on it. So you map the values in the vector, and then you take each value that has a type. You say the type of which is reference to is U32, and then you do what? You say checked add. So you do a checked add. So you do a checked add on it, and then you add what? You add a 1. That will give you check add on this. It will give you a result, right? A result or error. And then you do OK or um what is it? Okay, yeah, OK or so you take the so OK or so you get the OK value or this or this for the error. All right. So this is a string here or overflow. At the end of the day, if there are any errors, the first error is what you're gonna get returned here. I mean, in this result, the result will contain that, right? And then you collect this. You collect this. I mean, you don't specify any types here. When we collect, we just collect it, and the type it would collect to the type that is specified here. So we don't have to use the turbofish thing for it. And then you want to assert that that the values are now 2 and 3. Let's see what it checked. What is it? It checked add. Checked add is this is on. I mean, hold on. I think I know I think I've seen checked multiply or something before, but I don't remember. Checked add. Yep, it's on U32. It can also be on any of them. I think it will be the same thing. But it checked add will check the integer addition. Yeah, and it returns us an option. Yeah, that's true. Because I was trying to remember why we're doing OK or right. Okay, so it gives you an option actually, not a result. Check add gives you an option. So it will be some or none. Check that, John. compute self to the right hand side, returning none if an integer overflow occurs. So here, check add one gives us an option, and then okay or converts, yeah, okay or converts this option to a result. Yep, that's what happens. So if you see, wait, can I just do a search here? No, I can't, right? For the methods. Um, no, no, yeah, that gives us an option. So I can go here and actually say okay or yeah. So yeah, this converts this to a result for us. To transform the option T into a result T. So it only transforms um the only transform the okay or in this case the sum part, right? Yeah, leaving the error. So yeah, mapping sum v to okv and none to error. So but the argument you pass here, about the argument you pass to error. Argument passed to OKR, you get evaluated. Mm, okay. Yeah. Wait, okay, yeah. So it maps some V to OKV and none to to error. Okay. And with the error. So basically what I would do here for us is this obviously becomes the error, yeah, as we said. So here's another example here that would do the it will map this do a check subtraction on it, and then this of course becomes an option, okay, or, and then you say the error is an underflow. Yeah, yeah, because you're using a U32 unsigned, so you say underflow, you collect it. So we are certain that we're going to get result as error underflow. Okay, so that's fine. Um, but this is hmm, but hold on. I mean, this is supposed to be about using the from iterator from iter, but we do iter here. Would this be doing? But how does? Why is this on? Why is it under from iter? I don't believe it's doing the same thing, or is it? Wait, let's see. Uh, okay, so wait, but let's see here. So anyway, so Rust result implements from iterator, right? So that a vector of results can be turned into that, where we saw that already. Yeah. Um, once hmm, once a result error is found. Once a result error is found. So basically, you have a vector that has results that has a result te inside of it. You can iterate over it, yes. And the example that we were looking at just now, okay, yeah, okay. Okay, so I guess that the iter is working the same way as the from. Uh, From iter, I guess they're both they both I need to see how that's different, right? So this is from iter. How is this one different? I need to see that part. I need to see how it's different. In any case, why hold on. I think I can. No, it's not yet loaded. But anyway, if when that before that comes up, let's see. But how does it work when you have this? You go over the values, and then you say that you go over the values, and then when you have the first error, you get it. We're looking at it here, not here actually. I think it was, yeah, it was here. Okay, yeah. Mm, yeah, because we in the end would collect it. Okay, so we in the end would collect it, but you can do the same thing if you do a from iter, right? So if you basically say that result, I mean this the type and then from iter, it would be the same thing. Okay, okay. I think I would like to try this out. Why not? Why not? So if we have this like so, and we have the vector now that iter like so, but can I do a let r for example be, can I do a result that the vector of u32 and a reference to a string slice as a static lifetime and do, by the way, oh no, yeah, I was missing one thing actually here like so. Can I do, hmm, why I can do iter on this. Uh, Result implements from iterator. So what would be the problem with doing a from and so I guess this way you would, okay. I'm just checking something. Hmm. So you have from iter on result. Okay, but the moment you make this into, hmm, okay, but you can anyway do it another way. All right, I think I've seen what I wanted to see there. Let's proceed. So once an error is found, the iteration would terminate, right? So how that's done is we can have a binding here, strings, that is a vector that contains string values, string items here in the vector, and then we try to iterate over this by doing into iter, as by trying to get hold on, wait. You do into iter and then you map this. You try to do it, try to parse this and try to collect this. So if you succeed in doing this, right, um you would have a you have result that has like vector of things here. Otherwise, you would get the first error. So same technique can be used with option. But what it's saying here is that a vector of result and this can be turned into a result of vector. Let's write this one and see, because it's not clear what they're talking about here. You have a vector that has you have strings that is a vector of some strings. Okay, I think it's actually still our same old vector that we were using before now. Okay, but let's get rid of this one. Okay, and then what? And then you iterate over this. You said you were using into iter, create an iterator from values. But if I do iter, you return an iterator over a slice. That's the difference here. Okay, so instead I'm doing into iter. I want to create an iterator from the values, and then now you want to map it and say that each item here, you then want to parse it. Uh, I want to parse it to that type. It succeeds, you want to collect this into a result, but this won't work yet because there's no type annotation. So yeah, Rust won't know um how to convert this. We have to help it by either specifying the type here and saying that this is a vector of I think what they had here was result. Yeah, because this actually returns us a result, right? So parse gives us a result of I32 or parsing error, right? And then we're going to collect all of that, all of those results into something, right? So, oh wait, hold on. Yeah, so this is going to give us results. So we have result here, and we're going to be collecting that. Excuse me. So why is that a vector? Oh yeah, it's result that has a vector. Okay. Hmm. This is interesting. At this point, here we already have a result here. Once we do a parse, we would have results here, right? And then we collect this. We say that we now have a result has vector inside. Mm, I wouldn't imagine this to be the type, right? Would that be correct? How is it? How is it? Oh wait, this is you have an iterator, and then you at this point you have the value, individual value here. You map it each for each item in the vector, which is a string slice right now. You are just parsing this, and you get a result here. Yeah, okay, wait. What if I then did a mm, if I did this, this is going to be okay. I mean, this is I'm getting the actually this will convert this to an option. No, but that's not what I want. What I want is so uh we can also get the value. So I mean I want to see why this is the case. Why they say it's returning this. I don't get it. Doesn't make sense to me here. Um, can I do this? Hmm, I think we already looked at this before, right? Or maybe we can even say we can annotate the collect here and say, yeah, mm, yeah. So this what I expect to have is a result of I32 um, parsing error. This is what I expect to get here. Errors and on text arguments, but oh yeah, result. No wait. And on text two. What is this thing? Okay, I had. Okay, I installed this yesterday. Was it? Wait. Okay. So that's not it. Yeah. So there is. So this is this one, right? And I'm defined here with the generic parameters. Okay, and go back to my code now. Okay, wait. Um, wait, but hold on. This is supposed to be. This is like result of this and that. So what's the problem here? Why is this not? Why are you saying this is? Why is this problematic? This should be fine. Well, it doesn't work because I didn't get this issue here of Rust enum takes two generic parameters, but one argument. The value of items cannot be built over an iterator. Okay. Is, is this a different result type, by the way? Why is it? What's the issue? No, it's result actually. So what is the problem here? But anyway, let me let me see if I can see this error better. So it says expected two generic arguments. Are we missing something from the generic from the result? Excuse me, syntax. Oh, I think we were actually. Hmm. That we were actually right. This is strange. Okay, so I'll have expected one of these. Found that this is syntax error or what? Strange. This is how you collect. This is how you collect it. Even from the other example that we had before, that's what we do there. And this is also saying that this is unknown. I think that's very telling, actually. That is that's actually telling of this. So if if hmm, so what if I remove this from here? Okay. Now I get that. And the error again is that value of type I32 cannot be built from an iterator over what type of elements. Over elements of type I32. Hmm. Okay. A value of type this cannot be built from an iterator over elements of that type. Is that why they did it? I'm curious. So now you still want type annotations here. That's because you don't know this type here. Yeah, of course you don't know it. Mm. But but here you say if I say this is the vector, if I say this is a result that has a vector like so, that you are fine with it. Okay, so how does it work? You have a result. Why is this? Why is the value inside this? Oh shit. I think I finally get it. Hmm. Oh, it's am I wrong on this part? You have these values that you have this, you do into iter. What do we get with into iter? Exactly. Creates an iterator from values, the values that you pass to it. Creates an iterator from from a value. So yeah, so that's just going to be an iterator. That's it, right? It's going to be an iterator from the values, right, that we have there. And you can map this. And then for each element that is inside of the iterator, you want to perform an action like this function here. You do this. Yeah. How is this still a how is it's strange? I mean, I don't get it yet. It's about what's going on here. So each one now becomes um wait and when I do a map, I do a map. Hold on. I want to go to Iterator and say map. So map is going to take a closure and create an iterator, which calls that closure on each element. So map transforms one iterator into another. That's what it does. So you're going to take this iterator that contains, actually that contains values like so, and you transform it to an iterator that contains um, integer values. Like if you, I iterate two values if you succeed in the operation. Otherwise, like it would actually not one that contains integer values, but one that actually contains result values. Yeah, that's it. But why is a vector inside is what I don't get here. Why why would the type here, why would the OK variant of the result be a vector? Do you is it I mean this is yes, I agree that this is a vector, so but the vector has elements, and each element in the vector is actually of this type, right? It's a string slice. That's it. And that is what I mean, this should this should not be like so. I guess that's what's a bit confusing. Okay, you know what? I'm gonna ask this question here on ChatGPT, right? So the in Rust, given this function, I expect the um, collected container to be um, this is a result I32. Um, yeah, I think so. I32 and pass means error. Yeah, pass into error. How does it become result back? Okay, let's check our understanding of this. Um, yeah, iterator collect is polymorphic. So to collect into the concrete type that we provide, that we want, I mean, to collect into the container that we want it to go into, right? That's what you mean, right? The method of collect doesn't have a fixed return type. Yes. Instead, it can produce any collection type that implements the trait from iterator. Yes. Aha, okay. Okay. So by this, when we do this collect and we provide this type, we want to collect into this type. That's it. Because you wrote this, okay, I think this is what was confusing. What was confusing. Yeah, because I know this. Okay. So that's a key, that's a very key difference here actually. Send the compiler which collection type you want. That type annotation guides the interface, the inference. Okay. What does the iterator produce? The iterator is into iterator map this. So parse returns a result of this, which is actually correct, valid, what we were expecting. So the iterator is so the iterator is iterator item is this. This is going to be each item of the iterator. How does collect work here? Rust has a blanket implementation of from iterator for result. And it goes from, I mean, if you have TEC to give you TE, this means if you have a result TE, which is if you have an iterator of result TE, you can collect it into result of the types. I mean, you can collect it into a result of a different type where the OK variant is what is transformed, right? I already said. As long as the inner where C implements this. Hey, Abinite, so does that mean the first element would be an error and the other two would be valid integers? And does that mean the first element would be an error? Oh yeah, you mean in the other yeah, you mean in the one we were looking at, right? Which is like here, right? Yeah, yeah. I mean, um, so yeah, because it's hmm, there should be an error and the other two be integer values. No, I don't expect that we would actually even have any uh I expect we'll have an error. I don't think we would have I think it will terminate on the first error, right? So because because I think that's what we saw with the from iterator, right? The from iterator trait. I think that's what would happen. We should actually check it because so it says as long as the inner collection from type C can itself be built from the iterator. So yeah, that's what I think. We'll try it. We'll try it in a moment. Yeah, applying that here, our iterator, this collecting into results, like this. So vec I32 implements from iterator. Yes, therefore the whole thing works. And okay, so collect here tries to parse every string into I32. If all succeed, yeah, you get okay vec I32. Yeah. If any fail, then you get error. Yeah, I think is what I was saying. Yeah. Oh, he says that. You see that right there. Yeah. Say the terminator on the first error. Exactly. He says that there. So yeah. I think the thing that I was a bit confused. That was I was leading me down the wrong path was this. I was like it was like this is not I wasn't expecting this. So it blew me away first of all. Like, wait, why would we be getting this? But this is actually what we wanted to collect into. So let's write this and see ourselves. So we're providing this as like collect into this container basically for us. And then I think we just said results, we'll just print result. Um, so on. Okay, think this is it. Let's see what we get. Let's just run it. Yeah, that's what we have here. We have an error. Basically, yeah, we have an error. It's a parsing error, kind invalid digits. That's for the first one. So it would. So this would. So basically, essentially, I think the summary of this is that I think I just got a follow or something. Yeah, but I think that was that sound I was hearing. Yeah, the summary of this is really that we the way this would work is we can process an iterator or an iterator over some values or whatever, and then terminate on the first error, right? So we can just terminate on the first error or um, whatever transformation that we want to apply based on map or any of these intermediate operators, we can do it, right? So I think that's part of the processing that we're learning here. So it's really about failing the entire operation with collect. So that okay, that would be this. Okay. Hmm. This is for me. I think I would need more examples of this for this to sit very well because um, normally my expectation would be. I mean, the way I've been interacting with collect so far is to chain all of them. So, for example, like what I was doing here. Like yeah, I was also collecting here in this example that is commented out. I was also um I was also collecting here. See, I was processing the same thing we have, right? The same vector we have, going through them. Um, and at the end of the day, I was collecting errors to like a separate hash map, right? Based on a side effect here. We were using the same collect, but we were doing it. So why? So yeah, exactly. So why is this different, right? So why don't we fail on the first error here? Um, even though we're collecting, so we're doing a filter map here and doing the processing here. Why it's different is what? Hmm. I don't know. Does this click for you? Abby Knight. It's yeah, okay, sure. I also need to run in a bit. Yeah. All right, thanks. Bye. I mean, Epic, look at this. I'm trying to I want to get why it's different. So we what is the key? I think what we saw here was that it was saying the key idea is that collect is polymorphic. And yes, it does have a fixed return type. We get it. What does the iterator produce? The reason why collect works here is because vec I32 implements from iterator. Yes. Okay. Oh wait. Okay. Hmm. Okay. I think I'm starting to get it. Um, Cross has a blanket implementation of from iterator for results. This means if you have an iterator with this, as long as the inner collection type C itself can be built from an iterator, applying that here, our iterator has each item is the result of I32 and parsing error, collecting into result that is like so. And because vec I32 implements from iterator, it would work. Okay. And I guess this is why we decided to use vec I32 here. This is why we decided to collect this into a vector of I32. So if it works, if it succeeds, wait, sorry, hold on. I think, yeah, so if it succeeds, we have uh, an okay with a vector of I32. So wait, let's see. So if I get this out of the way and we run this, we would have um, a result that has that vector in it. Okay, okay. If you feel you get that, yeah, that's fine. Hmm. If we did this with this, do we have a problem? Okay, we don't have a problem because well, this is just a container. We're saying collect it into this, and the error, the error doesn't change. I mean, based on the definition of the function, it doesn't change. It will try to process this. What if I said, um, this would still work? Okay. What if I also say this will still work? Okay. And if this is now, I think I'm also getting tired tonight. I need to go sleep. Okay, so let's see. What's the issue? Did not compile it. I expected a type, found a trait. Okay, here. Yeah, error is a trait, so we can't use error directly. We need to use a type, not a trait. Okay, yeah. So, but the passing error works. That's fine. Okay, okay. I think I would need more examples of this. We do it. Can do that. Maybe tomorrow. Yeah, do that tomorrow to try to really understand a bit more why this works the way it does. I mean, I get it, but I think I need more examples, more practice, like um more cases of why this works, right? So it clicks. So just, but anyway, the long story short is that we fill the entire operation with collect. That's it. And it work, and the reason for that is, I mean, the reason why that works, why it both succeeds if everything is fine, is because it is because the type that we want to collect into has to implement the type in the type in the OK variant of the result has to implement from iterator, right? Yeah, for that to succeed. I mean, for it to be able to do that, for it to be able to collect. And if there's a failure, it fails on the very first, it terminates on the very first error. So I think that's the bottom line here. And the same technique can be used with option. So I let's continue tomorrow with this, right? So we'll continue to. I'll try to find maybe some more examples or some more cases um where we need to use to do this. Um, yeah, there's also, but I would want to stay here a little bit much more. All right, then I'll start my stream tomorrow at 10 p.m. Yeah. All right. See you. Have fun.